Okay, I'm going to start off the day by talking about the three basic types of polynomials. Okay, so we'll do 1, 2, and 3. The first one is called a monomial. And the key to understanding this is understanding this Latin root right here for mono. What does that mean? That means 1, right? So if we're talking about a polynomial, more specifically a monomial, then we're talking about a polynomial that only has one term in it. An example of that would be 3x. 3x is a polynomial, but it's only a monomial because it has one term in it. The number 5 is also a polynomial. Happens to be a monomial because I could write it as 5x to the 0 power, considered to be one term, so it would also be a monomial. That's the first one. The second one is a binomial. Now, just like the first one, what is the Latin root for bi? 2, right? Yeah. So that's going to have 2 terms in it. An example of that would be 3x plus 2. All of this together, right, is a polynomial, but there are 2 pieces that we call terms, right? There's that piece and there's that piece, so that makes a binomial. Can someone come up with their own binomial really quickly? Yes? 5x plus 7. There you go, dude. 5x plus 7, that's another binomial because it has 2 terms. Okay, following suit, what do you think the third one is? Trinomial. Very good. All right. And of course, the tri right there is right in there for us. So that means how many terms is this going to have? Trace terms. Very good. Okay, so how about 3x squared plus 2x plus 1, right? Collectively speaking, all of this is a polynomial, specifically a trinomial, because there are 3 pieces or 3 terms. These are the 3 basic types of polynomials. We have monomials, binomials, and trinomials. We're going to deal with all of them. Let me teach you about the parts of this, okay? This is the same box. So let me teach you about the parts, kind of like the parts of the car. If I gave you 4x and then to the third, okay? What do we call the number that sits out in front? Constant? No, that's the number that sits in the back with nothing going on. What's the number that sits out in the front? You're really close now. Starts with a Z. Coefficient, yes. Out in front here is the coefficient. Sometimes it'll be referred to as the leading coefficient. Okay. What do we call this thing right here? Yeah, that's the variable. Right? Or the base. And what do we call this piece up top? The exponent, right? And we just learned the rules of exponents. Or it's also called the degree. Okay? And the degree is the highest exponent. So that is important. The degree is the highest exponent right there. Okay, there are all the parts to a polynomial. The coefficient, the variable, or the base, the exponent, or the degree, and the degree is the highest. Everybody feeling good so far? All right, here's the second box for you, okay? I'd like you to determine the name and the degree. And here's A, B, C, and D. Okay, if I gave you 3x squared plus 5. First, let's figure out the degree. What is the degree of this polynomial? What would it be? It's the highest degree exponent. Yes. 2, yeah, there you go. 2, right? So the degree is 2. The degree is equal to 2. And how many pieces are there? How many terms are there?
2.
There are 2 terms, so what do we call that? A binomial. All right. Here's the next one for you. How about 5x to the third plus 7x to the fifth plus 2. All right, what would the degree be on this? The degree is 5. It's the highest one, right? And so the degree is equal to 5. And is it a monomial, a binomial, or a trinomial? It's a trinomial. Because there are 3 parts to it. Okay, here's C. Tell me what you think this one is. 3x to the third plus 4x to the fifth plus 6x plus 7. Ooh. This one's kind of different, isn't it? Well, let's get the degree down. What's the degree? Yeah, it's definitely right. Okay. So this is a 5th degree. We don't have a name for something with 4, right? What do you think? Yeah, 5th degree polynomial. You got it. 5th degree polynomial. And D, I'm going to throw a wrench at you. Not really at you. I mean, the problem. 3x all over 5x plus 2. What do you think that one is? What's your guess? What's your best guess? Trinomial? Okay, what do you think, Daniel? Binomial. What do you think? Anybody else? Good guesses, yeah. Binomial. Anybody else? Well, what's different about this example versus the other 3? There's a fraction. If there is a fraction involved, this is not a polynomial. Okay? It's called a rational expression. It's a completely different category. Tonight in the homework, they'll say, hey, is this a polynomial? Yes or no? If you say fraction in there, you say no. Everybody good? All right, great. Now that we know what polynomials are, the 3 basic pieces, the monomial, binomial, trinomial, we've learned the parts, we've learned the degree. Now we're going to start adding and subtracting them. So on to the next box here. Let's add 2 polynomials. All right, here is the first one. It's going to be 8x to the third minus 2x squared plus 6x minus 2 plus 3x to the fourth minus 2x to the third plus x squared plus x. Whew, holy cow. Jeez Louise. Ow. Scare myself. All right. In order to add these things, there's a special way that we do it. Does anybody remember? It's like a classic saying in mathematics. Anybody remember? Daniel thinks he knows it. Looks like he knows it. All right, what is it? Like terms. Okay, you have to add like terms. Very good. There's this phrase, right? Okay, what is a like term? There are 2 things that have to happen in order for a like term to actually be called a like term. They have to have the same base. Very good. And the same what? Degree. You got it. A lot of people understand you have to add like terms, but they don't know what that is, right? Same degree. So you have to have these 2 things going on in order to be called a like term. So let's identify our like terms. Let's start with the highest degree exponent that you see. Which one is that? 4, yeah. And what I like to do, I like to circle them. So I know that I'm looking at them, and there's no others that I may have missed. So, do you see any other x to the fourths? Nope. So I'm going to write that down, and I'm going to cross it off because I'm done with it. All right, let's go 1 notch down to our 3rd degree exponents. Do you see any? I see one over here, and I see another one over there. Please include the negative sign. Very important. Okay, how much is 8 minus 2? Good. Write 6, and then write down your exponent, x to the third, right? When you're done with that, cross those off. Okay, what's the next degree? Squares. I have negative 2x over there. I've got a positive x squared over there. What's negative 2 plus 1? Negative x squared. Let's get rid of those. Are you guys catching on to this? All right, what's the next one? Okay, a 6x and a 1x. How much is that? That's a positive 7x. Sweet. And last but not least, I have this minus 2. Tack it on the end. Take a look at the answer and let me know if you notice anything that is nice and fancy. Yes, what do you see? No, never mind. Yes, what do you see? Hurley. Yes, thank you. All of the exponents are in order from what? From greatest to least. Now, here's a question for you. What is the exponent on the 7x? What is the exponent on the 2? X to the 0. Very good. Now, when you have all exponents lined up in greatest to least, it's called standard form. Standard form of a polynomial. And all your answers should be in standard form. All right. Questions, comments, concerns about that one? Are you catching on? Yeah, all right. Sweet. We got 2 more boxes. This last one, subtract. So we're going to subtract 2 polynomials. And here they are. We'll go blue. How about 3x to the 4th minus 4x to the 3rd plus 6x squared minus 1. Subtract 2x to the 4th minus 8x squared minus 6x plus 5. Okay, the subtractions have a big giant warning. Why am I putting a warning there?
Because it's danger.
Danger. Danger's getting it wrong. Yes, why is the warning there? Oh, yes. Yes, that is absolutely correct. You have to make sure you do not forget to distribute your -1 to every single term that is after the minus sign. If you're going to get this problem wrong, that's where you're going to make a mistake, right there. So here we go. Let's start with the highest degree exponent. Those looks like a 4th degree to me, right? So let's write down 3x to the 4th. Oh, wait, there's more, huh? Well, this one over here. 3x to the 4th minus 2x to the 4th. How much is that? 1x to the 4th. Good. Cross it off. Let's go to the thirds. 3rd degree. I have a -4x cubed, and that's all that I see. So I'll write that down. Let's go squared. So I have positive 6x squared and a -8x squared, but I have a minus sign. So I'm going to go positive 6 minus a -8 is a positive 14. There you go. 14x squared. Let's get rid of that. I don't see any other x terms besides this -1 here, but be careful. It's a negative 6x, so that's a positive 6x. And then I have -1 minus 5. That's -6. My answer. The last box for you. Last box is a U try. Alright. I'd like you to try this. Once you get it right, put your hand up and we'll see if you have the right answer. And I'm going to make it a little bit more challenging by putting a number out in front. So it's going to be 8 times 4x to the 3rd minus 3x squared minus 1. Subtract 6 times 4x to the 3rd plus 8x minus 2. Now, what do those numbers out in front mean? Yes, that's right. You have to distribute the 8 into the first polynomial and the -6 into the second polynomial, and then you can add the 2. All right, take a look at the answer here. You should have got the same thing I did. I got 8x to the 3rd minus 24x squared minus 48x plus 4, and is my answer in standard form? Yes. All right, did we get it right? All right, very nicely done.